Alright, this is the last example in our whole section of notes. So I want you to read it again. I'm going to pause to let you read. You're going to pause to let you read. And then I'm going to talk about reading for understanding rather than just reading to get the gist. Alright, so we have a 13-foot ladder. I put that in my picture. It's leaning against the house. This is clearly, I hope, clearly the ladder. And this base is starting to slip. Alright, by the time the base is 12 feet from the house, now again, that's changing. So maybe we need to make a variable. Let's call that the distance from the house. Then this height is also changing, right? This is sliding down. So h is decreasing. Note to self. dh, dt, it's negative. And we don't know. Alright. The base is moving at the rate of 5 feet per second. Now that's the base is moving. The base is moving as an x. So that's a dx dt. And it's 5 feet per second. Now, since x is getting bigger as this ladder slips away, that's a positive value. Okay, so that's positive. Now, the first question asks how fast is the top of the ladder sliding down the house? So part A, how fast is the top of the ladder sliding down the house? So that's asking what the dt is. There we go. Since we've got a right triangle, I'm hoping you're thinking already Pythagorean theorem. So h squared plus x squared, that's 13 squared. Now the 13, you don't need a variable for because the ladder doesn't magically change values in the middle of sliding. It's always going to be 13 feet. So I want you to take the derivative. I'm going to have you pause it. I'm going to pause too. I'm going to write a bunch. I want you to check your answer with mine. So now, do you notice it equals 0 because the derivative of 169 or 13 squared, it's just a number, so the derivative is 0. Now, we have to know some other things. This is 13 and this is 12. I pointed opposite, but you can figure out at the moment we care about how much h is. So use your Pythagorean theorem to figure that out. You should get the square root of 13 squared minus 12 squared. That's 169 minus 144, square root of that. That looks like the square root of 25 to me. That's just 5. If you know your special right triangles, you already knew that one. Oh my gosh, I'm trying to add Christmas trees to this. I know you can't see that, but I can. It's kind of funny. All right, pen, work again. Here we go. So that's 5. Now, it is changing, so we needed to kind of not put it in until after we found our dh dt. All right, so now I'm going to substitute in my 5. My dh dt is what I'm looking for, so we're going to leave that. I have 2. My x is 12 at this moment in time that I care about, and dx dt is 5. That should equal 0. So I'm going to pause again, and you are too, and you're going to do a little math and see if you can get dh dt. Alright, so I did a little math, and my arithmetic worked out that dh dt is negative 12. Does that make sense now? Didn't we make a note that it should be negative because this h value is decreasing, so it should have a negative rate of change. H should be going down or reducing, so that makes sense. The question is, what are the units on that? Now it's an h and a t. Time is measured in seconds here, and our lengths are measured in feet, so this should be feet per second. All right, so that's part A. We're going to talk about part B. All right, so I erased some things to get them out the way, but in part B it asks at what rate the area is changing. So it's a rate, so we're looking for d area dt, dA dt. So we need to kind of have an area formula for a triangle. I hope you remember that 1/2 base times height is the area formula. So I can do dA dt, but maybe I better relate base and height in terms of the triangle we have. So our height we called h, so that was good. Our base we called x. That one we need to sub in. So let's go ahead and do that. So this is really a equals 1/2 xh. Now, we have to take the derivative. So let's do that. dA dt is equal to, that's a product, use the product rule. I'm going to do 1/2 x, and then I'm going to take the derivative of that second part, plus, now this time I'm going to take the derivative of the first part, and leave the second part alone. So I did the first part I left alone, took the derivative of the second, plus took the derivative of the first and left the second part alone. Now, erase some of these extra underlines. Now we can substitute in what we know. Now we're looking for a dA dt, so that one we are leaving. Now, do we know x? Why, yeah, it's 12 at the moment we care about anyway. dH dt, now that we needed. We needed to know that before we could do this part. And here it is. That's what we found the last time. Now also we need to do 1/2. I'm going to totally run out of room. So hold on, it's going to look funny. I'm going to pinch this in. Woo! Okay, that was fun. Don't you wish you could do that with your paper? 1/2. Now dx dt, what did we say that was? It was 5. That was one of our givens. And h we figured out over here. I want to say it was also 5. So, now we just have to plug and chug. I'm going to pause and let you do that. You do it too. Now, I'm hoping that makes sense that it's negative 59.5. My handwriting's even worse on these tablets and not with the stylus, so I apologize. But it's negative 59.5, but I want to make sure we talk about the areas. If you need to pause and look at my work to make sure you agree with that negative 59.5, you do it. Okay, what does that mean? First of all, it's negative. The area is reducing at this moment in time. It's also measured, its area, and our distances, our lengths were measured in feet. So it's square feet is for area per minute. So the area is reducing by negative 59.5 feet per minute, feet squared per minute, excuse me. I'm not sure who really cares about that, but it is in fact the case. Now I'm going to pause again and get rid of the clutter, and we're going to talk about C. So my program wouldn't let me just erase the clutter, so I just made a new page. Now it asks what the rate, the angle with the ground changes. So that's a d theta dt for sure, because it's an angle. But we kind of need to figure out where theta is, and since it's with the ground, here's the ground, so we need to put that in. All right, so that means we have to use sine, cosine, or tangent. So use sine, cosine, or tangent. Pick one. You can pick any of them. Look, you have all the values. I would imagine it would be better to use one with the hypotenuse in it so that you don't have to have another dH dt or dx dt, because if you do use those are variables and they have to be used as variable rates. So you could use sine of theta, and that would give you h divided by 13. Opposite over hypotenuse. You could use cosine. I'm going to use sine, but you could use cosine, and that would give you x divided by 13. You could use tangent, and you would have h divided by x. Any of those are fine, but this one requires you to use a quotient rule with two variable terms, and I'm not so sure I like that, or if you move the x over. So I think I chose not to do that, but you can absolutely do it. It will work. Now, I'm going to go back to my sine. I know the derivative of sine is cosine. And don't forget your d theta dt, because the derivative of the inside is sine. All right, now the derivative of this, I think you need to remember that when you have a constant on in the denominator, you can just write it as a fraction, 1/13 h. It's a little easier to take the derivative, or a little easier to see the derivative. That trick is a useful one and a time saver rather than using the quotient rule. Anyway, that's going to be 1/13 dH dt. When you bring down the 1 and change it to a 0, it's going to make that h just kind of go away. It's a 1. All right, now we have to substitute things in. Now that one we knew before. That was negative 12 from before. So hey, we know that. We know this guy from before. Excuse me, that's what we're looking for. We know this guy from before. That's 1.19. So I'm going to let you substitute in, d theta dt, and then you pause, and I'm going to pause, and we're going to come up with an answer. All right, so I got negative 0.343. That's in radians. It's a theta, so it's in radians, and you can only do calculus in radians. If you want to change it to degrees and you took the derivative right here, you are going to get the wrong answer. So make sure your calculator's in degrees. You get the answer in radians. If you have to switch it to degrees at the end, do it at the end. Calculus formula for the derivatives of all the trig functions are based on radians. We did the proof in radians. Otherwise, there's a conversion factor that's involved with this. You'd have like a 1/360th or so, I don't know. There's this crazy conversion factor built in with the chain rules. Don't do it. Moral of the story, don't do it. Use radians, convert after you get your answers. All right, radians per, in this problem, I believe it was seconds. If I'm wrong, you're just going to have to fix me because it's on the other page. All right, so that's the end of that problem. Come back to class on Monday with any questions you have. All right, peace out. Happy weekend. See you on Monday.